Hey there, future elementary teacher. Are you staring at a giant list of vocabulary for your CSET exam, feeling like you're about to get lost in a galaxy of terms? Don't worry. Take a deep breath. Today, we're going to connect all these dots, from the tiniest atom to the largest galaxy, and turn that feeling of oh no into OHH, I get it now.
This video is proudly brought to you by TeacherPreps.com, your ultimate partner in exam success. If you want the complete study guide and access to realistic practice tests that will truly prepare you, head over to our website. Click the link below and start boosting your confidence today.
Let's kick things off with physical science, the rulebook for everything around us. It's about how matter and energy behave and interact. Rule number 1 is the conservation of mass. You can't create or destroy matter, only change its form. Think of it like Legos. You have a box of bricks. You can build a car, then take it apart and build a house. Those Lego bricks are our atoms. At the center of each atom is a nucleus, with positive protons and neutral neutrons. Whizzing around them are the negative electrons. The type of atom is determined by its number of protons, and we organize all these types on the periodic table. Now, what happens when these atoms get together? They have a chemical party. The starting ingredients are the reactants, and the new things they form are the products. We have several types of reactions. A combination reaction, where two atoms hold hands to become a new couple. A decomposition reaction, where a couple breaks up into individuals. A single replacement, where one person cuts in on a dancing couple. And a double replacement, where two couples swap partners. And then there's a combustion reaction. That's when something reacts with oxygen to create heat and light. Think of a campfire. If a reaction releases heat like that, we call it exothermic. If it needs to absorb energy to happen, making things feel cold, it's endothermic. Remember how we said atoms are made of charged particles? Well, the movement of electrons is the secret behind electrical energy. And the energy holding atoms together in molecules? That's chemical energy. But what makes things move? Forces. Gravity is that universal attraction between anything with mass. Friction is the force that resists motion when two surfaces rub together. And when all forces on an object cancel out, we have balanced forces, and nothing changes. But when one force is stronger, we get unbalanced forces, and that causes a change in motion or acceleration. Now, let's explore the fascinating world of life science, the study of living organisms and their processes. The basic unit of life is the cell. Think of a cell as a tiny, bustling city. The nucleus is City Hall. It holds the DNA, the master blueprint for everything the city does. Now, every city needs power. In plant cells, the solar power stations are called chloroplasts. They perform photosynthesis, using sunlight to turn water and carbon dioxide into sugar, which is food. In both plant and animal cells, the power plants that burn this sugar to create usable energy are the mitochondria. Cells with the same job group together to form tissues. Tissues work together as organs, and organs team up to create organ systems. Your circulatory system is the highway, with the heart pumping blood through veins and arteries. Your nervous system is the internet and telephone lines, with the brain, spinal cord, and nerves sending signals everywhere. Your digestive system is the refinery, breaking down food into nutrients and energy. And the master blueprint for all of this? That's DNA. When organisms pass this DNA on, it can be through asexual reproduction, creating an identical clone from one parent, or sexual reproduction, mixing DNA from two parents to create a genetically unique offspring. This mixing is what creates genetic variation. Life doesn't happen in a vacuum. It thrives within complex interconnected systems. A group of the same species is a population. All the different populations in an area form a community. And when you add the non-living or abiotic factors, you have an ecosystem. Within this ecosystem, we have roles. Primary producers, like plants, make their own food. Consumers eat other organisms to get energy. And decomposers are the cleanup crew, recycling nutrients from dead matter back into the system. How do organisms survive here? Through environmental adaptations developed over generations through natural selection, where the, quote, fittest survive and reproduce. That's Darwin's big idea. Finally, let's explore our planet and beyond with Earth and space science. Our Earth has a solid inner and liquid outer core of metal, a thick, semi-solid layer called the mantle, and the thin, rocky shell we live on, the crust. This crust isn't one solid piece. It's broken into plates. The theory of how these plates move is called plate tectonics. This movement is what causes earthquakes, builds mountains, and creates volcanoes. The rocks themselves tell a story. Igneous rocks are born from fire, cooled magma, or lava. Sedimentary rocks are made of tiny pieces of other rocks pressed together over time. This is where we find most fossil records. And metamorphic rocks are old rocks that have been transformed by intense heat and pressure. Now let's look at the Earth's systems. The lithosphere is the solid land. The hydrosphere is all the water, from the massive oceans to your water bottle. This water is always moving in the water cycle. The atmosphere is the layer of gases that gives us air to breathe and regulates our climate. And the biosphere is everywhere that life exists. All these spheres interact. For example, the sun's gravitational pull and the moon's is the force behind ocean tides.
So you see, it all connects. Physical science gives us the atoms and the forces. Life science shows us how those atoms build incredible, living systems. And Earth and space science gives us the stage where this grand play unfolds. If you want to get to know more or even take a practice test, you can visit us at teacherpreps.com or click the link below.